Good evening students, welcome back to the class, and in today's class we are going to discuss about the EMF or cell potential of a cell. So in the last class, that is on Saturday, we have discussed about the cell potential little bit. So let us do a quick revision because in this session we will require that concept. Okay, so cell potential. Now you know that in the Daniell cell there were two containers in which oxidation was occurring and reduction was occurring. So the reduction side was what? Cathode was present, and in the oxidation side anode was present, right? Here this is the negative terminal and this is the positive terminal. Here what was the reaction? Cu2 plus was getting reduced. Okay, it was converting to Cu. Here what was happening? Zn was converted to Zn2 plus. It was releasing 2 electrons. So these 2 electrons were these electrons taken up by copper, because you know there is a connection with a wire attached with a voltmeter and a battery, and here salt bridge was there. Okay, so here zinc electrode was here and here it was the copper electrode. Okay, so here reduction and here oxidation, right? Now you see, when we say cell potential, we mean to say reduction potential, means the capacity to get reduced. So as you know that this side does not get reduced, only your right hand side get reduced, so this has more capacity to get reduced. Okay, if you say in other words, the the cathode, in the cathode side the reduction takes place, so there will be a difference in the electron because electrons are moving from here, right? So this creates the cell potential or potential difference. Is it clear? Because electrons were moving from the anode, okay, to the cathode, there will be a difference of potential, difference of the number of electrons in simple terms. So this is how electromotive force or cell potential is present in a cell. Is it clear, this thing? So now you see one thing here, EMF. Okay, so EMF is calculated by E cathode minus E anode. Okay, EMF can be calculated by E cathode minus E anode, means difference in the potential, electrode potential. Okay, so is this clear? EMF is calculated by E cathode minus E anode. Okay, so this is the difference in the potential potential of cathode and potential of anode. Or you can say cathode is to your right, so E right hand side minus E left hand side. So this way is also another way that you can represent that. Is it clear? Now in the Daniell cell, you know that oxidation redox reaction was occurring, right? So redox reaction means what? Oxidation and reduction takes place simultaneously. So in this beaker oxidation and in this beaker reduction, right? So you cannot separate them because as a whole, in the whole cell redox reaction was occurring, and you know that in the redox reaction both oxidation and reduction is occurring. So you cannot calculate the single potential of any electrode, whether it be anode or cathode. You cannot calculate because EMF, you see, for EMF what we need a potential of cathode minus potential of anode, but it is not possible because individually you cannot calculate, because it is always, if oxidation is occurring means reduction is occurring, if reduction is occurring then oxidation has to be occurring. Okay, so you cannot calculate their calculate the potential individually. We can calculate individual potential with the help of a reference. Okay, and that reference is called the standard hydrogen electrode. Okay, so this reference is called the standard. Okay, so in short you can say SHE, standard hydrogen electrode. So this standard hydrogen electrode has a cell potential of 0. Clear? It can act as anode, it can act as cathode both. So your reference electrode has potential 0, and this reference electrode, which is known as the standard hydrogen electrode, it can act as anode, it can act as cathode both. So now what you will do, you have to create a cell, you have to make a cell where you will take only this portion of the Daniell cell and you will attach it here. Okay, so now you have attached the left hand side electrode with the standard hydrogen electrode. So what you will get, you know, here this is the anode na. So how this will it will be converted to cathode, because you know that the standard hydrogen electrode can act as anode as well as cathode. So whenever it is connected with anode, it will act as cathode, and when it is connected with the cathode, it will act as anode. So like that you will get a complete cell. Okay, so this was your Daniell cell, right? This portion is your Daniell cell. Now the zinc or the anode part, okay, this anode is connected with the SHE. So now this SHE will be your cathode. Clear? Then this was your copper electrode which was acting as cathode. This is your SHE which is acting as anode. Is it clear now? It means that Daniell cell, you cannot calculate the individual potential of anode or cathode, but if you connect with SHE, you can take out their individual potential, because this does not make any difference in the potential of the anode or cathode, because the potential of this is 0. Is it clear? This is the diagram of a standard hydrogen electrode, and as you can see that the electrolyte or the solution present in a hydrogen electrode is HCl. Okay, 1 molar HCl. So this one. Next, you see, you can see a platinum wire attached in a tube. So this platinum wire is again covered with a foil, platinum foil, and you can see hydrogen bubbles here. Okay, in white particles you can see these hydrogen bubbles are present. So, and there is a inlet here in the whole system. From here hydrogen gas is allowed to go inside, and this hydrogen gas creates bubble here. Okay, so now let us see what happens here. Okay, the reaction. When you know that okay, you know that SHE can act as anode. So what the reaction is when it acts as anode? When it is acting as anode, you know oxidation will occur. Clear? Oxidation. So this H2 will get oxidized as H plus, here it will be 2 and 2 electrons. Is it clear? And when it is acting as cathode, you know reduction will occur, right? So the vice versa reaction will take place here. So this hydrogen will undergo reduction. Is it clear? So this is the thing, this is the setup of SHE, and these are the reactions that you have to remember. And also you have to remember that the electrode potential of the standard hydrogen electrode is taken as 0. Is it clear? Okay, now why this standard electrode potential is used? In order to calculate the cell potential of a electrochemical cell. Okay, and as we have already discussed that it has to be get connected to the individual electrodes, so let us do so. Suppose this is the zinc electrode and this will be your copper. Okay, so with zinc it will act as cathode, isn't it? So it will become SHE, and this SHE will here act as anode, and this is your copper electrodes. Now you can calculate the, if you experimentally do it, you can calculate that the E0 cell here is 0.76, and for this particular cell it is 0.34. okay, so you know that electromotive force E0 cell equal to E right minus E left, right? So you put the value here, it will be 0.76 equal to 0. For hydrogen electrode it is 0 minus, you don't know this, okay, so El. Now if you bring, E not this side, it will become minus 0.76. okay, so it will become minus 0.76. Again for this, if you calculate, if you use the same method, what you will use, 0.34 equal to, now your E right is copper, so it will be ER, we don't know the value, minus SHE is 0, so what you will get, ER equal to 0.34. So individually we have got that the zinc electrode or the anode is having minus 0.76 cell potential. Obviously this will be negative and this is positive, isn't it? Why? Because you know that this is the cell where reduction takes place, individual cell or half cell, and this is the cell where oxidation takes place. So when we talk about reduction, obviously this value will be negative, okay, because here no reduction takes place, very less tendency to get reduced, so this term will be negative and this term will be positive. Now in order to calculate the electromotive force or EMF, what you will do, you just have to subtract it again. Individually you have got na zinc and copper. Now again you use the same formula in order to calculate that. What you will do, E right is what, 0.34, isn't it? So what you will do, you will write 0.34 minus, now again minus of 0.76. if you calculate, you will get 1, isn't it? 1 volt. So this is the EMF of the Daniell cell, because we are calculating about Daniell cell, so 1 volt is the value. Is it clear? So all this will be calculated in terms of volt. This much for today, and in the next class we will learn about the electrochemical series. Okay, so this electrochemical series you have little bit of idea, okay, but again we need to go in details, how does it work in electrochemistry, why what is the importance of it. So this thing will cover up in the next class. Thank you.